In this video, I'm going to demonstrate how to prove congruent triangles using a two-column proof. Remember, there are 5 ways we prove triangles are congruent. We do it by side, 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 angle, side, angle, side, angle, 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 side, and hypotenuse leg. Alright, you have to prove that these things in each triangle or triangles are congruent to say the triangles are congruent. Our first example. Given line segment AC is congruent to line segment BC, just like any other proof, make sure you mark what they've given you. And M is the midpoint, alright? So M is the midpoint of this line segment down here. Prove that triangle ACM is congruent to triangle BCM. So if you need to break apart the pictures to see that you have 2 triangles here, that's okay. But I'm going to start to prove. So step 1 is our given information. Line segment AC is congruent to line segment BC. And we know that M is the midpoint. That's given. Alright, so if I know the definition of midpoint, which we said earlier, if M is the midpoint, that means that line segment AM is congruent to line segment BM. That's by the definition of midpoint. Midpoint. Okay. Number 3. I know that side CM is shared by both triangles in our picture, so we know CM is congruent to itself by the reflexive property. So now I know that this side is congruent to itself. So looking at your triangle, you have 3 sides that are congruent to each other. So we can conclude that triangle ACM is congruent to triangle BCM by side and side, side. So we say it's by side, side, side. Here's our next example. Given that AD is congruent to EC, so those line segments are congruent to each other, and BD is congruent to BC. So remember, this sign right here is parallel, so I know those sides are parallel. So remember, it was the parallel lines, alternate interior angles, alternate exterior angles, that information. So I know that angle DAB is congruent to angle CEB. Alright. I also know from what was given that BD is congruent to BC. So let's start writing down some of my information. So step 1, you were given that AD is parallel to EC. Those line segments are parallel. And you are also given that BD line segment is congruent to BC. That's given. Alright. I said earlier about knowing that the angles in parallel lines have alternate interiors, so I know these angles are congruent. I also know that these angles are congruent. Alright. So, step number 2. I know that angle A is congruent to angle E. I also know that angle C is congruent to angle D. Okay. By the alternate interior angle theorem. And that's really all the information I need to prove that these triangles are congruent, because look, I know an angle, and a side, an angle, and a side. So I know that triangle ABD is congruent to triangle EBC by angle, side. Now, you could have also proven this triangle was congruent by angle, side, angle if you remembered right here that angle ABD was congruent to angle EBC, and those are vertical angles, so you could have said angle, side, angle. So it's two options for it here. Here, our next picture, I know that VW is congruent to UW, and angle X is congruent to angle Z. What I did over on the side is kind of break apart the triangle so you can see the congruent pieces. So I know that VW and UW are congruent, and I know angle X and angle Z are congruent. Alright, so the first thing I'm going to do is write down my statements that were given. Line segment VW is congruent to line segment UW, and angle X is congruent to angle Z. That's given. Right. So look at what you have here. Both of these triangles share and they have an angle W. And if you look in the big picture here, angle W is in both triangles. So I know that angle W is congruent to itself by the reflexive property. So I have enough information now to say these triangles are congruent. I know this triangle is congruent by angle, angle, side, angle, angle, side. So I know that triangle XWD is congruent to triangle ZWU by angle, angle, side. All right, last example. So we're trying to prove that triangle BCE is congruent to triangle DCE. So let's look what we have here. I know angle 1 is congruent to angle 2. So let's mark that off. And angle 3 is congruent to angle 4. And that's all we've been given. So let's get started. So step 1. I'm going to give my given information. So angle 1 is congruent to angle 2, and angle 3 is congruent to angle 4. Given. Our next step is, look here, we have these little triangles inside of big triangles. If you need to take them apart to see, you have 2 big triangles here and 4 small triangles inside. Okay. So I know that AC is congruent to itself. And if you look in both of the big triangles, they have line segment AC or side AC. So I know side AC is congruent to itself. That's by the reflexive property. So I'm going to show that the big triangle here, we've shown that these 2 big triangles are congruent to each other. By angle, side angle, angle, side angle. So I know that triangle ABC is congruent to triangle ADC by angle, side angle. As a result, I know, because these triangles are congruent, that the corresponding parts are congruent. So I know that BC is congruent to DC, and I know that BA is congruent to AD. All right, so I'm going to use that to help prove other things. So let me write that down. I know that BC is congruent to DC. And we know it's by corresponding parts of congruent triangles are congruent. Right? So I know that this part right here is congruent. And next up, I know that CE is congruent to itself by the reflexive property. And lastly, look, we have a side, an angle, and a side that is congruent. So I know that triangle BCE is congruent to triangle DCE by side, angle, side. And proof. Thank you for watching. I will talk about this more in class, and I have some extra practice for you.